So we did all of this by maybe multiplying through -1 or not, but adding the columns down to eliminate. So this section right here is elimination by multiplying first, but you might need to multiply, this is where it's different, one or both equations through by a positive or negative number other than 1 in order to eliminate a variable and solve. So it might be multiplying through by 3 or 10 or -4. You just have to figure out what to use to get rid of one of the variables. So let's look at this first one here. Solve the linear system by using the elimination method. So I have this equation and this equation. As they are, I can't get rid of variable, can I? No. So I'm just going to pick one that I want to get rid of. I'm going to pick x that I want to get rid of. What would I have to multiply through by one of those equations in order to eliminate x? Which one? 3 on the bottom one. Not negative. Just regular 3, because then it'll give me -6. So I'm going to do this. The whole thing by 3. Okay? So I'm going to write over the first one. I'm not changing that. Not changing that first one at all. Then I'm going to multiply everything inside here by 3. So then I get -6x plus 9y equals -15. Am I ready to eliminate now? Yep. Now I can get rid of the x's. And then I'm just going to add down just like you were doing before. 7y equals -14. Oh, but I'm going to set up my ordered pair because I know I'm going to need an ordered pair. Divide by 2, excuse me, by 7, divide by 7, and y equals -2. So I'm going to stick that right in the y spot of my ordered pair. All right, it doesn't matter which one you plug it into. So I'm just going to plug it in to the first one. It doesn't really make a difference. I'm going to take this y equals -2 and plug it into there. So that would be 6x minus 2 times -2 equals 1. 6x plus 4 equals 1. Subtract 4. This is often. This happens in my Algebra 2 class too. People stop there and they say x is -2. Ah! It's not. What should you do to finish this? Divide by 6 and make sure. Oh, wait a minute. That does not equal -2. What does that equal? -1/2. Okay, be careful. It's very common. So my x is -1/2. So my answer is -1/2, -2. Just take your time and be sure, okay? Right, so that's that one. Let's do another one. So say you're working on this. You look at them, they cannot eliminate as they are. I have choices. What do you want to get rid of, the x or the y? What do you want to get rid of? Wait, yeah, we can get rid of the x. What would we do if we wanted to get rid of the x? Times the or multiply the top one by -2, right? Okay? Or let's say we want to get rid of the y's. What would we multiply the top one by? -11. You see that you have options. So let's do the top one by -2. I'll get rid of x. So I got to do that by all 3 things inside there. -4x plus -2y equals 18. And then I'm just going to keep the bottom one the same. And then add down. Okay, this helps me get rid of those. Perfect. And then this is 9y equals 27. I'm going to set up my ordered pair. Divide by 9. Y equals 3. Okay, now it doesn't matter. Let me just show you something. You could take this y equals 3 and you can put it in there. You could put it in there, or you can put it in there. It doesn't matter. You'll get the same answer. I like to look at it and say which one would be the easiest. To me, the original top equation would be the easiest because y is just sitting there by itself, right? That's what I would do. So 2x plus 3 equals negative 9. Minus 3, minus 3. 2x equals negative 12. Divide by 2. X equals negative 6. Negative 6, 3. That's my answer. Isn't that beautiful? Now stop a second. Say you're taking your test and you want to make sure. What would you do? You plug it in. You could even use your calculator. And you could just plug in 2 times negative 6 plus 3. Does that equal negative 9? You can check that way, right? Just to make sure you're doing it right. Okay, one more of these. Oh, there's all sorts of stuff going on here. So, I'm going to keep the first one the same. Because that's lined up how I want it. I have to move this one around so they're lined up. So I think, it doesn't matter, but I think I'll just subtract 5x from both sides. Now I'm going to write it the correct way here, so they're lined up. I have negative 5x. I have a positive 9y. So it's plus 9y. And 5 is positive, so I'm going to write positive 5. Now they're lined up. We could get rid of x or y, but let's just get rid of x. So I have to multiply both equations by something. I have to think of the least common, here's a vocab word, least common multiple of 3 and negative 5. What's the smallest number they both go into? 15, right? So I'm going to multiply the top equation by positive 5. That'll get me to positive 15. And the bottom equation by positive 3. That'll get me to negative 15 here. So let's rewrite our equations and do that. And multiply all three things. 15x minus 21y equals 25. Negative 15x plus 27y equals 15. What do you think is the most common error that people make when they're doing this? I see it all the time. Okay, Kira, what did you say? Oh, the add sometimes, but that does happen. The most common thing is people will multiply these two and not the last one. And that's a problem. If you're changing that equation by multiplying by 5, you got to multiply all the numbers. And that's so common. I see it all the time. So keep that in mind. Try and remember not to do that. Okay, let's add these down now. This goes away. That's 35. Thank you. Yes, it is. Yeah, I wrote it right on here, and I wrote it wrong here. Okay. Is everything else right? Looks like it. 15, 27, 15, yes. Okay. Now let's add down. That goes away. This is negative 8y equals 40. I'm going to set up my ordered pair because I know I'm going to need it. Divide by negative 8. Y equals negative 5. Okay? Now, again, you can choose to put it in any of them. It doesn't matter. I'm just going to take it and put it in this second equation here. So I have 9 times negative 5 equals 5x plus 5. And negative 45 equals 5x plus 5. Subtract 5 from both sides. Negative 50 equals 5x. and divide by 5, so my x would be negative 10. So the only thing that's different about this is that you're multiplying through by numbers other than negative 1 sometimes to eliminate. Okay? All right. Let's do these last two things. You row a canoe 10 miles upstream in 2.5 hours and 10 miles downstream in 2 hours. What is the average speed of the canoe? So we're just asking average speed here. So I'm going to use distance equals rate times time because I can see that. That's what we're working with. Distance equals rate times time. So I have an upstream and a downstream situation, up and down. What's the distance that's upstream? 10. I don't know how fast I went, but I know that upstream I took 2.5 hours. So if I divide both sides by 2.5, what is my speed upstream? Does anybody know? 4. R equals 4 miles per hour. Upstream. You just divide by 2.5. Okay, downstream, same distance. Don't know how fast it took me, but I know it was for 2 hours. It took me 2 hours. So if I divide both sides by 2, what is my rate for downstream? 5 miles per hour. Now this is a question that really doesn't have anything to do with systems. It could be. You could substitute. But I'm going to have you sit over here for the rest. Raymond, would you move, please? Thank you. So it says I need the average speed of the canoe. Wait a minute. If you have two numbers and you need their average, what do? You add them together and divide by 2, right? It's the average speed. So I have a speed of 4 and a speed of 5, and I'm going to cut that in half. That's how you find average. That equals 4.5 miles per hour. That's all there is to that one. Generally, you're going to have to come up with 2 equations. I think this was just an odd one stuck in there. All right, Mr. Alvarado bought a total of 20 pounds of grass seed at the nursery for $168. He paid $9 per pound for the Kentucky bluegrass and $6 per pound for the tall fescue. Never heard of it. And Y in pounds of tall fescue. So my X is my pounds of Kentucky bluegrass, and my Y is the other one. I need 2 equations. Let's start with this 20 pounds. How do I use that to write an equation? 20 pounds total. How do I use that to write an equation? It's X in pounds of bluegrass and Y in pounds of fescue, and I have a total of 20. What do? X plus Y equals 20. This is pounds of bluegrass, pounds of the other one. Total of 20. Then I'm going to write a money equation. How much is the bluegrass? $9 per pound for bluegrass. How much is the other one? $6 per pound. And I spent how much? $168. I have my 2 equations. You can do this. Yes, you can. Okay, I need to solve. So that means I got to multiply probably the top one through by either -9 or -6. Which one you want to do? -6? Okay, let's do -6 and we'll eliminate Y that way. I'm going to take it down here. -6x plus -6y equals -120. Just kind of put a line through that so I'm not confused. Now I know that I'm using these 2, and I'm going to add down. So 9x to minus 6x, or add -6x, is 3x. Those go away. Equals 48. Divide both sides by 3. And x equals 16. But I know you wouldn't leave your answer as just 16. Because what is x? What is x? Representing. You wrote it up here. Pounds of Right, pounds of Kentucky blue. 16 pounds of Kentucky blue. You don't even have to do any work. If you take 16, back up here into this equation, what is 16 plus what gives me 20? 4. There's my phone. 16 pounds of tall. Brooke, you can tell me to turn it off. Okay.